Hey guys, I just wanted to hop on and go over endothermic and exothermic. These were in the video that you guys watched yesterday on Ed Puzzle, but I just wanted to be sure we kind of got all of the information down. Some of the things that we talk about on this chart we may not have covered yet, and that's okay. Just write them down and it will all fall into place once we get there. So an endothermic reaction is one where the system absorbs energy, right, or heat from the surroundings. Okay, so if you have a beaker with some chemical reactions happening inside, this is the system. Everything around it is the surroundings, and there is energy going into that system. Okay, so on the flip side, exothermic is the opposite. The system is releasing energy or heat to the surroundings. Okay, so if you had a similar beaker with chemical reactions happening inside, energy would be being released to the surroundings. Okay, those are really terrible drawings, but you get the drift. So if you have energy being removed from the surroundings, which you can feel, into the system, then this is going to feel cool. Okay? Vice versa, if you have energy or heat being released to the surroundings, which again, you can feel the surroundings. You can't reach in there and feel the system, but you can feel the surroundings. These will feel warm. Okay? Let's talk for a second about some variables or some things what they'll look like in endo and exothermic. For endothermic, your variables are positive. Okay, so Q, which remember was heat, is positive. Delta H, which is enthalpy, which you might have taken a few notes on yesterday, but maybe not. Those are positive. Okay, over here, Q, which is heat, is negative, and enthalpy is also negative. Okay, so another thing that I want you to be sure you understand is that for endothermic, heat is a reactant. Okay, so if you have, let's say you have photosynthesis, 6 CO2 plus 6 H2O produces sugar and 6 oxygens, heat would be written over here. It's a reactant. Heat is a product. It's produced, it's released for the exothermic. So photosynthesis is not an endothermic reaction, so I'm going to write cellular respiration, which is the opposite. Heat is a product over here. Okay. What else do I want you to be sure you write down for endo and exo? Let's just write some like everyday examples down. Endothermic examples would be melting. And we're going to draw some particle diagrams in a second, so this makes sense. Why melting and vaporization, right, which is just evaporation. Those are endothermic. Other examples of things that absorb energy from the surroundings are refrigerators. I don't know the whole physics and mechanics of it, but that's how a refrigerator works. It is not pumping in cold air into the fridge. It is removing the energy, removing the heat from the air, and that's why it feels cool. Okay, and then photosynthesis. Okay, examples of exothermic are freezing and condensation. Right, the opposite of melting is freezing, the opposite of evaporation is condensation. Any type of burning or combustion, those are exothermic. And cellular respiration, which is the example of the chemical reaction we wrote. Okay, anything that releases energy or releases heat. So I just wanted to draw a quick particle diagram because it's really easy to kind of get in your head about freezing being exothermic, because it's weird, right? Because it's supposed to feel warm, and this is why. Okay, let's draw two little diagrams, one with solid going to liquid going to gas, and then another one with the arrows going in the opposite direction. Okay, let's draw the particle diagrams. Solids, oops,
Teachers and students, pardon me for a couple of quick announcements. Just a reminder, seniors, that project graduation tickets are now on sale in the lobby. They'll be there during Falcon Lunch today. Make sure you come get one and enjoy the evening. Our levers.
Okay, hopefully you can hear me. Draw these particle diagrams. Low energy, higher and higher energy. This is
Thursday
melting.
will be an officer election for next year's art club, so come on down and check it out. Also, teachers, just a reminder that tomorrow we will be testing in some of your rooms for Algebra 1. Make sure that we get all the materials covered and or taken down in your room.
Okay, so these are the phase changes. If you are increasing in energy, means you absorbed energy, so these are endothermic.
Good night's rest, eat a nutritious breakfast, and get here early and ready to go.
Okay. These are decreasing in energy. These are losing energy, so these would be exo.
Schedule tomorrow.
So hopefully this clarifies some of this. I'm going to turn this off. I don't even know if you can hear me, but hopefully you can. And I'll move on to the next video after announcements.
Also want to remind everyone